All right. Hello, everyone. Sorry we are a little late. We had some technical difficulties, which is always a possibility when you're doing the live streaming. So, welcome to the Quarkus Global Hackathon office hours. This is July 15th. This is actually our fourth and final office hours. So, we appreciate all the speakers in the past and everyone who has either attended live or has watched them after the fact. So this week we got a great presentation for you. Alexey is going to go into Quarkus extensions and how to create them. But first, I want to kind of kick things off a little bit. Lexi, can you go to the next slide for me? What we're going to do is we're going to go through. Really, I'm probably just going to fast forward and go into the Quarkus extension. Next slide. But I want to kind of set the stage in terms of where we're at here. One more. So this is like I said, the last office hours, and next Wednesday is the final day for submissions. So we're going to have a session on Wednesday next week at 10 a.m. to just go through the basics of what you need to do to make sure you submit correctly. Obviously, all of the information is on the DevPost site. In terms of we're asking for things like a short video to do a description of your application, kind of show us around a little bit, and then obviously giving us links to source code and those things. So the dev post submission will walk you through all of that. We just want to make sure we got a session that will kind of go through those things for you in case anyone has any final questions. And then we're going to go into this period of eligibility review. We are going to down select the finalists, and so we'll make an announcement. At this point, we're looking at probably doing the top three for best overall, and then having two or three finalists for each of the subcategories. So we'll send that out, and then on Friday, August 14th at 10 a.m. to 12 p.m. Eastern Standard Time, we're going to do a live judging session. So the judges are going to review, discuss, talk about all the submissions, and they're going to actually enter their scores in real time. And so you'll be able to see their thought process, what they're talking about, and then their scores. And so we'll do some awarding at that point. All right, next slide. So what I want to do is we're a little bit shorter for time. So obviously this video will be available on demand. You're probably watching on demand now. Um, and this is where all of our pre-existing office hours are, the opening ceremony is, as well as a lot of great content for the Quarkus community. I really want to draw attention to these weekly or biweekly insight sessions that are going on. They really are an hour long and they take a deep dive into a certain topic or extension or any issues people are having. It's a great learning mechanism and it's fun to watch. So with that being said, Alexi, let me turn it over to you and start talking about Quarkus extensions from here.
Okay, thanks. Hello everyone. So as part of this session, I'm going to develop a Quarkus extension and also an application using that Quarkus extension. So let's start with the application, since I think you are more familiar with this. So I have a project here, which is an application, Quarkus application. It's really the default generated REST easy endpoint. There is really nothing more than that. You can check the POM. It includes REST easy, and that's the only extension. And there is a hello resource, which is a REST endpoint returning hello. Let's first, as a start, make sure that it works. I'm going to start it in dev mode. Okay, go to my web browser, refresh, and it works. Great. So now I'm going to start my extension project. So the easiest way to start an extension project would be to generate it. There is a Maven plugin, Quarkus Maven plugin, that can generate a project, basic project. I hope you can see this. Probably make it bigger. So it goes like this. Maven coordinates of the Quarkus Maven plugin version. I'm going to use the latest available 1.6.0 final. Then create the extension, and then I'm providing the group and artifact ID of the runtime artifact of my extension. In this case, org acme and acme Maven resolver and the version. So I'll just generate that. So the reason I called it Maven resolver is because I'm going to develop an extension which will provide a Maven artifact resolver to applications. Okay, so it's done. If I look at this at the directory where I executed this command, I will see my Quarkus project, which is my application project, and the generated Acme Maven resolver. So I'll just go into this project, and I will also open my IDE and import this newly generated extension project. There's some. All right, so okay, there is some kind of exception, but let's ignore it for now. So as you can see, or maybe you can't really see it well, but there are three modules. There is a parent POM, nothing really special about it. Make it bigger. It just includes two modules, deployment and runtime. There is the Quarkus version that I'm going to be using for developing this extension 1.6.0. And it imports Quarkus BOM. Ignore this deployment part. We are getting rid of this in the next version. It will just be Quarkus BOM. But for now, this is the way it is. All right, so the most interesting part will be in these two modules, the runtime and the deployment one. If I look at my runtime module, it's actually empty. There is no classes. Literally, it's an empty jar. Okay, so, and the runtime applications using my extension will add the dependency on the runtime artifact of this extension, not the deployment one. And this runtime artifact will end up in the lib directory of the Quarkus application. So this is literally the runtime dependency of the final application. The deployment one, however, is going to be used only at build time. So when Quarkus is building an application, it resolves the deployment artifact behind the scenes and using it to build the application. Simply speaking, that's the way it is. So the deployment one, however, includes a class called processor, and it's also very, very simple. It doesn't actually matter how it's called. The key thing here is this method annotated with build step. And it is producing a thing called a feature build item. So a build step is literally a build step, a Quarkus build step. So I can have multiple methods annotated with build step, and they will be producing something contributing to the build, basically. In this case, all our processor does is contributing this feature build item. Okay, so let's just, it's a usable actually extension, so let's just install it. It's done. Okay, and now if I go back to my application and to its home, I can add a dependency on my extension. ID is org acme artifact ID. I think it's acme maven resolver, and the version will be, what was the version, 1.0 I think. All right, so now if I actually start, I could have kept it running, but anyway, let's start it. So if I start my project now, I hope you can see it here. Can I? Yeah, if it is better. So now, among the installed features, before it was just CDI and REST-easy, and now I actually can see Acme Maven Resolver. It doesn't really do anything. Obviously, we don't have any code in there except for this feature. So the goal of this feature is basically to just display what extensions are used by an application. All right, well, that's a start. So now back to my goal. I want to use a Maven resolver in my application, let's suppose. So if I didn't have any, an extension providing this Maven resolver, which I actually don't at this point, and I still wanted to have a Maven resolver, this is what I would do. I would use Quarkus API because it's easier to get the Maven resolver initialized. There are a couple of classes. So one is Bootstrap Maven context. Let's see. Well, before it is resolvable, I should add a dependency on the jar that contains that class, which is Quarkus artifact ID Quarkus Bootstrap Maven resolver. All right. If I now go back here, I can actually import this class. And the other one, so this is not the resolver, this is so-called Maven context. What it does is it simply figures out the context, the configuration, the settings of the Maven used in my environment. Well, in the environment that the application is running in. And Maven artifact resolver, let's call it resolver. Now I will want to initialize them, and I will just do that in the constructor. Allow resource. Okay. There will be some exceptions, so I will just do this in main context. Done, and the resolver, Maven artifact resolver, and it'll take the context. Just to catch all the extensions. I won't go really, I'll just be very rough with them. Whatever is thrown, I will just rethrow, and I will create a couple of other endpoints that use them. So path, let's say local repo. If there are questions, you can just ask me, because I'm going to move quickly since I don't really have a lot of time.
Alexey, you can take your time.
And if anything, you can always ask your questions on Zulip in the hackathon stream. I monitor this, so in case you will have questions that I will not cover here, you can always ask them there.
And Alexey, feel free to take your time, because if we're recording this, people can consume it on demand. So.
Okay. Okay. So this one, what I did here, I just exposed my a path to my local repository on my computer as an endpoint, and just as an example, of course, just to illustrate the things. And this one here, I'm going to display something, well, let's say special. So if you go to the website called quarkus.io, you can see that it lists a bunch of extensions here. So actually this list of extensions comes from a JSON file. So it's generated from a JSON file. And that JSON file is actually a Maven artifact. So I will just, as an example, resolve that file and display its content. Its string, and here I will use the resolver, resolve artifact, old artifact. I will just hard code the coordinates of that file. Simpler will be Quarkus bomb descriptor JSON, classifier null, type JSON, and the version is 1.60 final. Take the latest, correct, then get artifact, get file, the path. It will throw an exception, of course. I will just rethrow it. Okay. Runtime exception. Okay, I think I'm done. So just to recap, I introduced two fields. I initialized the Maven artifact resolver and added two endpoints to read my local repository path and resolve an artifact from a repository and display it as a result. Okay, so let's see whether it works. Okay, so hello. Oh, it's not what happened. See what I did wrong. Path, text, yeah. So string. Okay, let's. Oh, let's see. Should we try again? No. Oh, I removed hello by mistake. Well, sorry about this. Anyway, I'm not going to re-enable it, but the local repo works. This is the path to my default local repository on my machine. And if I hit from JSON, I actually get the JSON file containing those extensions, as you can see. So, okay, well, kind of cool. Well, ignore this. I hit the wrong endpoint, so this exception is not really relevant. Okay, so this part works, right? The thing is that if I try to use, where is my project? Here it is. If I try to use this in native mode, this will, of course, not work because Maven Resolver is using, well, it's component-based. The wiring of components is performed at actually runtime. The class path is scanned, and then there is dependency injection and so on. And this makes it literally impossible for static code analyzer to reason about it, right? So it will not work. I will not launch the native build right now just to save time, but you can try it. It will not work. So I will. I think I will take it step by step. The next improvement that I want to do is I don't want to initialize these this Maven resolve and the context directly in my resource. I want them to be injected, and actually we can do it right in our application. So let's just do this. But if you look at these classes, this is the source code of this class. They are not annotated with anything, so they are not CDI injectable bins. And if you want to inject something that is not CDI injectable by default, you need to have a producer. So we're just going to create a class which is going to be a producer. Let's call it Maven context producer. All right, this is going to be a CDI bean, so I will annotate it with singleton. JavaX inject singleton, which means that the CDI implementation will create only one instance of this class. I will literally copy this code from here to this class, except I will change the constructor name. It will be Maven context producer. All right. And here I will simply remove this constructor and I will say inject. Inject. Okay. Here just see when this class is invoked, I'll add some logging. Print. Okay. Maven context producer constructor, and then it will be producing these two objects. Producers, public, bootstrap, maven context. Maven. It doesn't matter what I call this method. The fact is that it is a producing method and it will return the context. Right. And the same here. Will be called Maven Resolver. Okay. Maven Artifact Resolver. And I think that's it. So now I'm just going to be injecting instances of these classes from this producer. Let's see if that works. So if I refresh this page, it actually works. If I look at the logs, I can see that my producer got created and and produced those two objects. But here's the thing. Let's build an actual application. Clean package skip test. The test will fail since I removed my default endpoint. Okay, so I'm building my application, and now if I launch it, jar target my runner. As you can see, it started. We can see my resolver. Well, we can ignore that. We're not using actually it. But okay, now if I go and hit this endpoint, it does work. But what I see in the logs, this context producer was created and initialized the resolver on my first request, which is kind of not a nice thing. So it happened lazily. So if we are talking about fast boot time and then immediately serving requests, we really would like to avoid this. We would really like to eagerly initialize all the things to be able to serve requests, already fully initialized. And this will be the first thing that we will use our extension for. Let's do this. So now I want to move this producer from my application to the extension. So every application that is using my extension will benefit from this producer. Let's do this. So it's kind of very easy. I'll just copy it. Copy. And I'm copying it to the runtime artifact since I really need this class at runtime. I'll just adjust the package. This will be, what is that? Org acme Maven resolver. Oh, of course, I need to add some dependencies here because it doesn't really depend on anything. So, dependency. Again, we need this bootstrap resolver, so it will be IO Quarkus. Actually, I could just have copied it from this application. Okay, anyway. Quarkus bootstrap Maven resolver. That's one thing. Then the other thing is CDI annotations. So what I'm going to do is I'm simply going to add a dependency on another extension, which is called arc. So arc is a CDI implementation that is used by Quarkus. So it definitely includes all the necessary annotations. One thing to remember: if I add a dependency in my, if I add a dependency for my runtime artifact on another extension, I have to reflect this in the deployment artifact. So I'm going to make my deployment artifact depend on arc deployment. Arc deployment depends on core deployment, so I'm not actually losing core here. I'm just replacing one dependency with the other. And that is almost it. One thing that I need to do to make it actually work, I need to add another build step that is a little bit special. So what I'm doing here is I'm going to register this producer as a CDI bean. I have to do it explicitly in this case. And this is how it's done. Additional bin build item. Call it build producer. Okay, done. And build producer. Produce. Here I'm just producing a build item which Quarkus will treat as a, in this case, it will be adding whatever classes I add here, it will add it as CDI beans. Use builder, build, add bean class, my producer, Maven context, producer class. I think this is it. So let's build my extension and install it. And I'll rebuild my project. Again, if you have any questions, you can ask me the questions. Okay, so I probably need to adjust something in my application. My application, there it is. Okay, I need to remove this class. Since I moved it, now we have two producers for the same class. So I removed one from the extension. I can also adjust my phone. Since my Acme Maven resolver is providing the Maven artifact resolver, I can simply remove the dependency on the Bootstrap Maven resolver from my application. It will be brought in by my extensions now. Okay, I think this is it. Let's try it again. Okay, so if I launch it now, I don't really see it initialized. Oh, right, it's not. Okay, so what I did, so it still works, but it's not eagerly initialized. So what I just basically did is just I moved this class, this producer class to my extension, but it's still initialized lazily. So let's make it being initialized eagerly. And to do that, so how to make initialized during the boot in Java? Oh, when you launch an application, what you launch is a main class which is generated by Quarkus. And everything that is in the static init block of that class will, of course, be initialized at boot time. That's how Java works. So I just need a way to put the initialization of this bean, this producer, into that static block. And here's how it can be done. Quarkus includes a concept of a recorder, bytecode recorder. I'll create a class called Maven context recorder. I will annotate it with recorder. And I will add the following method. Init Maven context bin container. And I will call this bin container. I will ask it to instantiate my producer. Context producer class. I will say a few words about this just in a second. And I will add another build step here. I will annotate it with record. Execution time. runtime init. Record runtime init. And I will need an instance of my Maven context recorder, which will be provided by Quarkus build to me, and an instance of bin container build item. Import, and now I'll simply invoke my recorder. Bin container get value. Okay, so let me just go over this code. So as I mentioned, I will build my application for now. As I mentioned, the way to plug things into the static init of my generated Quarkus application would be to create a class called recorder. So every method in this class, which is called from a build step, will be, the bytecode of this method will be recorded and copied into the static initializer of the generated Quarkus application class. Okay, so this is how it's happened. So here I just define a method which I want to record, and I need to call it from a build step. So I have my processor here. I say it's a build step. I want to record what happens here. So I'm asking to inject an instance of my recorder and an instance of my bin container. Because I don't want to just create this class myself using its constructor. I want to make it available as a CDI bin. So for that reason, I'm actually asking the bin container to do that for me. Okay. Oh, it makes sense. So let's build my extension. Oh, yeah, I need to build my extension first. So the reason I'm not using the dev mode right now is just for that reason. I just want to show you how, first of all, I need to rebuild my extension all the time. And the other reason is I really want you to show at which point during the build and runtime the invocations are formed. So now, as you can see, I launched my jar, and now I can see this producer being created as part of the boot, right? So now if I go back to my endpoint and I refresh, it's not initialized here anymore. It's been initialized at boot time. So that's kind of the first step, let's say. Now, if I compile this application to native mode, I can actually do this. Native. Well, it will not work. The reason it will not work is I actually mentioned that because the Maven resolver is performing its discovery of its component at runtime using class loaders and initializing things on demand. So that makes it, in some cases, actually impossible for static code analyzer to make sense of that. Okay, so, and here is another reason I chose the Maven artifact resolver as an example for an extension. It consists actually of two parts. If you take the resolver, there is a part which is initialized, which doesn't really depend on your settings. So whatever settings you have, this system will pretty much be the same. There is this kind of static part, let's call it that, right? And then there is the part which is equivalent to repository session, which actually depends on your settings. So like my local repository path. right? If it's possible to build an application that will just use a single, that will not be configurable. So make the resolver work, but it won't be configurable, which is not my goal. By the way, it's finished. So let's see how it works. So this is my native application, and you can see it doesn't even start because there's something not available, and static compiler basically failed to build a working application out of this. So, so back to this Maven resolver, let's say architecture. So there are two parts. The one that does not depend on the configuration, and the one that actually does depend on your settings. So they need to be initialized separately. Why? Because in native mode, to make it work in native mode, what we need to do is, okay. All right, so let's go back maybe to this error, and I will try to explain it a little bit differently. So the reason it didn't work is because there are some classes that are missing, that are not included into the native binary. So our goal now is to actually add those classes to the native binary. And the way we're going to do this is we're going to split initialization. We're going to create another producer here. Yeah, okay, new class. Start fresh. New class, repository, system producer. So what I'm doing now, I'm creating a producer for the part of the Maven resolver that is static, that does not depend on the configuration. I'm following the same pattern as before. I'm just creating a CDI bin singleton, and I'm creating classes, adding fields for the objects that are going to be static, repository system. That's one system, right? Final remote, there is another one, remote repository manager. Okay. And import. Public repository system producer. Try, and I'm going to initialize them in a very familiar way. Bootstrap in context. Maven context. And I'm going to initialize them from the context because it provides them. Get this, and the repo manager context get repository manager. Again, exceptions. Whatever exceptions there are, I'm just going to rethrow them. And I'm going to produce them. Produces public repository system. It doesn't matter what I call this method, just return the repository system. And the same for the manager. Produces public remote repository manager. Okay, this producer is done. What I need to do next, I'm going to the recorder. I'm adding a similar method, but for the other producer. You can see it looks exactly the same. Good. And I'm going to go to my processor, add this bin here, add this producer here, bin class, system producer class. This done, and here is the trick. It's going to be pretty much the same, but with a slight difference. Init repository system, same, the class same. Only the execution time will be different. This execution time will be called static init. So there are differences between the runtime init and static init. Both of those are actually about static initialization, but there is a bit of difference. Let me just quickly go check what I did everything that I needed to do. Okay, I'll just build my extension, launch the build, and then I will say a few words about those execution times. And I am launching my build. Okay, so what's the difference? So as I said, both of these will generate a static initialization code, but this one, runtime init, will actually be executed when the application boots. But static init, in case of native binary, well, the state of this of objects initialized in static init will actually be serialized directly into the native binary, and when the application starts, the state of those objects will simply be copied into the memory. Okay, so they will not be reinitialized at boot time. Their state will simply be restored from the recorded bytecode. I should have added, I will do it now, a logging so you could see the difference. Repository system producer constructor. Well, it's too late now to launch the build, but anyway. Alright, so now if I launch my application, oh, there is still a problem, but it looks. Of course, okay. So now look, I have this producer that produces these two objects, but I'm actually not using them. So to make use of them, I need to go back to my Maven context producer and actually consume those. Repository system and remote repository manager, repo manager, right? And right, okay. I'm going to do here, sorry. Just to reuse them, I'm going to do the following thing. Main context config set workspace discovery. So there is a method called set workspace discovery, which by default is true. It's not really very much important in this demo. I will disable it. What is important is I want to initialize the repository system from that producer that I just added, and the remote repository manager, repo manager. Okay. So, and everything else should be the same. Enter application. Okay. Again, if you have any questions, just feel free to ask.
Alexi, there is
right?
a question
So
that came in earlier about, I think it may have come up a couple of times now, is it possible to do a bytecode analysis during the build steps with Quarkus?
uh, to debug the code, yeah, that's
Yeah, I'm
possible. You
assuming.
can actually dump. Yeah, there is it should be somewhere on our website or blog or something that yeah, you can dump. There is an option, command line option, especially if you launch in dev mode. There is an option to dump your all the generated classes during the build into a directory, so you can analyze them. You can use tooling, some kind of tooling to analyze them, or yeah, yeah. So that's possible, right?
Okay.
I don't think.
He clarified actually. He said not during debugging. He says, the analysis using ASM.
Um, yeah, I think so. I don't exactly remember the option just off the top of my head. I would need to look at the code or documentation, but yeah, there is such an option to do this.
Okay, we'll take a look. I'm taking a look now, and then obviously, as everyone knows, the Zulip chat is probably the best place. If you can't get it
Yeah,
answered here, obviously that's a good place to go to as well.
right. All right. So I built my application now in native mode. So now if I launch it, here's the interesting thing. Well, first let's see that it works. Okay, it does work. So when I launched my application, I see that the Maven context producer got called. This is expected, but we don't see the Maven repository system producer being called when I actually launched my application. And the reason it's not called is because it was called at build time. The bytecode of that method and the state of those objects was serialized and directly into the native binary. So when I start my application, this let me show you those. These two objects, repository system and remote repository manager, they are actually not created when I boot my application in a traditional way. So their state is simply restored and they're passed to this constructor. But this one is actually important to initialize at boot time, because if you look now, if I look at let's another endpoint, right? Local repository. So this is my default repository. Now, if I stop my application, go to my settings, and use a different path, and now I launch my application, if I refresh, it picks it up, right? So this is the important bit. This part has to be really initialized at boot time to pick up my settings, right? While this part like repository system and this remote repository manager doesn't really have to be initialized at boot. So it can be serialized directly into the native image. And now it looks like it works. Now the last bit in my presentation, really, what I wanted to show. So I changed my local repository. Now if I go and try to resolve this platform JSON, it actually fails. If I look at the error, it will say that this wagon implementation is not available. Right? So it appeared like it did work, and the reason it appeared that it worked because this artifact was in the local repository, and this wagon implementation wasn't really necessary to resolve it. So to add full support for this, to be able to resolve remote artifacts, this build my application. Where's the build? So here's what I added here. So by launching my application and asking to resolve a remote artifact, I realized that some classes were missing out of my native binary. And it mentioned this class, HTTP backend. So this is the way to add those classes for me. In Quarkus, you can create a runtime initialized class build item. And yeah, that's basically the way to include those into the build, static build. And then there is another one. How do I know about them? Well, I basically launch my application and see what's missing. The other thing is this class HTTP wagon will be created by the Maven resolver using reflection. And to make it work in Growl, I would need to register this class as a reflective class. In Quarkus, you're doing it this way. You're creating reflective class build item. False, false, it means what should I include? What kind of support for reflection I need to include? Methods and fields, in this case it's false, false. Just the class to be able to instantiate it. And the last one is I will be using HTTPS to resolve remote artifacts. So Quarkus provides a simple way to enable SSL for an extension. Your extension will just need to produce extension SSL native support build item, and the feature is this name of my extension, basically. And once I have this, and the build is about to finish now, that I expect it to work correctly. Let's see. So I will right away just change my local repository to make sure it does not exist. Let's see. There's something actually here. Now I will start my application in native mode. And it downloaded the artifact. And I can see in the logs that my native application downloading from central this JSON artifact, and it displayed it. Right, so if I stop my application and go back to this is the path to my temporary repository, my application. You can see this artifact downloaded. And that's basically it. So we could recap. So as you can see, it's not really, there are not so many classes in my extension. There are literally 4 classes. They're not big. There are a couple of CDI producer bins that look very simple, I would say, one and the other one. One is producing the bits that are put into static init and serialized directly into the native image. And the other one produces the stuff that needs to be initialized at application boot time. Then there is the recorder, which also looks very simple, as you can see. You just get the bin container and ask it to create those producers. And the processor class, which is a little bit more tricky, I would say. But once you get familiar with these build items, I think it will not look as scary as it may at the first sight, I would say. And as to my application, you can see that it just, what I needed to do is to add a dependency on the runtime artifact of my extension. And then I'm able to inject both of these objects. I could have just only resolver or also the Bootstrap Maven context. And that's it. So in case you have any other question, so please feel free to ask, or we can continue the discussion on Zulip if you have.
There was a couple of questions that came in. One was, why was the SSL part in the end necessary?
Mm-hmm. Well, that's very easy. If I look at the logs, look here. So I'm downloading from HTTPS. So that implies SSL, right? So if it was HTTP, it probably wouldn't need to be required, but in this case, the SSL-related classes and the API is necessary for the resolver to work. So by including this build item, this SSL support, Quarkus will simply make it easier for you to figure out. I could just not include it and add more build items to, make it work, but it's really a convenient way to add SSL support for the extension.
All right. There's another question that says, is the naming of the methods with the build steps annotation important?
No, not at all. It could be called anything, whatever makes sense to you, really.
All right. And this one was going back a little bit further into the demo. Hopefully it has the right context. So this, at one point, the state in the app then reflects only your state, so not from the user running the app. Does that make sense? Can you go back to your demo and remember about the app state?
Launch the app. Oh,
The question says, so I think it's when you were presenting something, it must have showed a state, and it said that the question was, the state in the app then reflects only your state, not the state from the user running the app. Does that make sense? I'm not sure if I followed the demo.
okay. When I was, I'm not, to be honest, I'm not sure I understand really this question, but when I was talking about the state and serialized state, I was talking about, some objects whose state does not depend on the configuration. So there could be some objects whose state will not depend on the user. So they're static for everybody. Let's say for every user of the application, some states will be the same. They will not change.
Perfect.
But some could be specific, right? So they will depend on the configuration. So there is a split, right, of a static state and something that is kind of environment specific, let's say.
Okay. I think that clears it up. Well, thank you, Alexey. I really appreciate it. That's a heavy topic, but an important topic for Quarkus and the Quarkus ecosystem. Obviously, one of the main draws to developers is the extensiveness of the ecosystem and the fact that more are added every day, and the fact that it allows other service providers or software vendors to create, extensions for their applications, which obviously only grows the ecosystem for Quarkus overall. So obviously there's a lot more. If you do some searching on the Quarkus YouTube channel, there's more information on extensions and how to build them. But Alexey, I really appreciate it. Thanks for your time. So
Sure, you're welcome.
with that being said, I
Makes sense, yeah.
apologize for the delay. What I'm going to do is I'll probably try to edit this video so it's obviously a little more concise, so folks who are watching it can have a better experience. But thanks for sticking with us. And then once again, I can't stress enough the Zulub chat is the place where all the Quarkus developers reside, right? And that's the best place to get your questions answered. I'll try to keep an eye on the questions, especially to some of the attendees today, to make sure that those questions get answered. So with that being said, that's the end, and thank you for joining. We appreciate it.
Yeah. Thanks, guys. Good luck and goodbye.